All right, we're in lesson 8.4, properties of rhombuses, rectangles, and squares. So first thing we got to start with is what is a rhombus, what is a rectangle, and what is a square. They are very similar and very different. Let's just start with talking about angles. So when it comes to a rhombus and the angles, the main thing is that the opposite angles are congruent. So opposite angles are congruent. I did some abbreviations. So A and C are congruent, and D and B are congruent. Okay. For the rectangle, for the angles, they are all 90 degrees. And you see this little square in the corner. That's the symbol that tells us that it's a 90-degree angle. And for the square, it's the same exact thing. The angles are all 90 degrees. So we see the little box in the corner, just like with the rectangle. All right, so now looking at the sides. For a rhombus, all of the sides are congruent, okay? Just like with the square, all of the sides are congruent. So let's put for both the rhombus and the square that they are all congruent. And I'm just going to use the congruent symbol. And the rectangle for the sides, it's very much like the parallelogram where the opposite sides are congruent, but they're not all congruent. So we're just going to say opposite sides are congruent. All right, so those are like the basics. There's more theorems to these shapes, but those are the basics of it. There's also this Venn diagram, which is very helpful. If you notice, all three of these are a parallelogram because all the sides are, or the opposite sides are parallel. And if we just specifically look in this circle, all of these in the circle have 4 right angles. So like the squares, all 4 of these angles are right, meaning 90 degrees each. And same thing with the rectangle, all of those are 90 degrees in each corner. And then in this circle over here, this circle of the Venn diagram is talking about congruent sides. So the rhombus has 4 congruent sides, and the square has 4 congruent sides. And you can see the square is right in the middle of the Venn diagram because it is both all right angles and all congruent sides. Okay, so that's kind of the layout of the Venn diagram, but the main thing is also to notice that a rhombus is a parallelogram, a square is a parallelogram, and a rectangle is a parallelogram. It's just kind of breaking it down into more specifics. So let's flip the page and let's get into our first example, example 1. For any rhombus QRST, decide whether the statement is always or sometimes true, and draw a sketch to explain your reasonings. So let's do a little sketch. These are always kind of awkward to draw, so do the best you can. I'm noticing they're telling me what the angles are called, Q, R, S, T. Just make sure to go in order around. And they say angle Q and angle S are congruent, which is always true for a rhombus. The opposite angles are always congruent. Next they say angle Q and angle R, which is actually only sometimes true. This would be true to have Q and R congruent if it were a square, which we can think of a square as a rhombus. A square is a rhombus, it just all the angles happen to be 90 degrees, right? We see the opposite angles would be congruent, it's just they would also be 90 degrees. So sometimes true. In this case, Q would be congruent to R. A square would be more appropriate of a name to give it, but it still is true for a rhombus because a square is technically a rhombus. Okay. Classify the special quadrilateral and explain your reasoning. So we're trying to figure out what name should we give this shape right here. First things first, I see all of the sides are congruent. So that's telling me this is either a rhombus or a square. And the thing that's going to tell me which is the 70-degree angle. Automatically, I'm putting a rhombus because all the sides are congruent, but we see we have a 70-degree angle present, so that's telling me that it's not a square. And if I wanted to break it down further to get all these angles, I know this angle across opposite would be 70, and then these angles would each be 110. But that's not really what the question was asking for. I just know it's a rhombus because all the sides are congruent, but the angles were not 90. Flip the page. Getting into some more theorems. This one says a parallelogram is a rhombus if and only if its diagonals are perpendicular. Perpendicular, this has a fancy symbol. It's kind of like an upside down T, but what it really means is it's creating a 90-degree angle. Now this is specifically talking about the diagonals. So you can see here we got an if and only if statement. We got to put something in these spaces. I see the upside down T symbol standing for perpendicular, meaning forming a 90-degree angle. We just have to name the two diagonals. So I see one diagonal is BD, and the other diagonal is A going to C. All right, so this is a rhombus because with the two diagonals intersecting, they make a perpendicular relationship. So they make a 90-degree angle. This one says a parallelogram is a rhombus if and only if the diagonals bisect the opposite angles. So bisect meaning cut in half, and the opposite angles. Okay, interesting. So that just means that this angle right here and this angle right here, they are going to equal the same thing. Okay, so if I say that this whole angle, angle D, is 80 degrees, that means that this angle is 40 and this angle is 40. Okay, I also know angle C, if angle D is 80 degrees, then angle C is 100, which makes this angle 50 and this angle 50. All right, so let's go ahead and apply this into some practice problems. I'm noticing some trigonometry is going to be used. If you need support on trigonometry, talk to your teacher about getting some extra help. But this problem says the angle WZV, so WZV is this angle right here. Okay. I know that if this is a rhombus, that means this angle and this angle are congruent. So that is 34 degrees. Okay, next, WVZ. So WVZ is this angle right here. I know that since this is a rhombus, that this is going to make a 90-degree angle. Okay, XYZ. X, Y, Z. This whole angle right here. I know that this angle is 64, so I know when I add the consecutive angles up, they should equal 180. So I'm just subtracting 64 away from it, and that's giving me 112. And then YXV, YXV, so Z, which is this angle right here. This would also be 34 because the opposite angles are going to be congruent. So since both of these are 34, that means both of these are 34. Okay. So now we're getting into some trigonometry. So I'm not going to go into depth because I don't have the time on this video. But if you need some support, ask for help on trigonometry and your teacher will send you some videos to watch. But WY is this diagonal right here, w going to y. I see I have a 7, so that makes this a 7. Easy enough. xy. Xy is, let's see, right here. I don't really have anything to tell me what this equals, but what I do have is a triangle. And so if I pull that triangle out like this, I see this base is 7. There's a 90-degree angle here, and this angle is 34. And so I am solving for this side, right? I'm looking for this side. So I know this is my opposite, this is my hypotenuse, so I am using sine of 34 equals 7 over x for hypotenuse. We could just do a little cross multiplication, and that can rearrange my question to be 7 divided by sine 34, which is going to give me 12.5. Okay. And last but not least, xv is this right here, which I notice is the height of the triangle. And I already have 3 of the sides, right? Like I know my hypotenuse is 12.5, and I have 7, and I'm just finding the last side. So this is just using the Pythagorean theorem, right? And if I do a little bit of simplifying, I know this is 156.5. 7 squared is 49. All I got to do is just subtract 49 on both sides. And what does that give me? 107.25 equals x squared. And we'll just square root both of the sides. So I have x equals 10.36. So that is what xv equals. Flip the page. Running out of time, so I'm going to have to go through this part fairly quick. A parallelogram is a rectangle if and only if the diagonals are congruent. So I see this diagonal, and which is AC, and this diagonal, which is BD. So those sides have to be congruent in order to make this a rectangle. And my recorder is running out of time, so I'm going to pause it here and do a part 2 for the video.